Welcome to the public AI for You Cafe on April 15th. And today the speaker is Fabienne Gandon, and I thank you that you are here. And the title is Linking Natural and Artificial Intelligence on the Web. As always, we are starting slow as the participants are coming in. I'm all welcoming you. Hello, my name is Carmen McWilliams. I'm from Grassroots Arts and I'm partner in the AI for You project. So welcome. Please take notice that this session will be recorded. The link for the recording you'll find later on the AI for You platform. No confidential information shall be shared in this cafe. All speakers express their personal views and opinions. This is not necessarily the official AI for You project opinion. And as we have now the audience coming in, welcome again. And I explain once more what the cafe is about. The cafe is a public space, an online forum to gain insights into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. So now that you are here, welcome everybody. This is an interactive session. Fabienne will make his presentation, and please feel free to ask questions. You can write them down in your control panel on the right side. There is a menu called questions and chat. You can write them in there. I will see them and will later read them to Fabienne. And if you want, you can also raise your hand. There is a hand sign in this control panel. If you click on it, I see that you raise your hand, and after the presentation, I may give you the microphone. So feel free, but be aware the session is recorded. So now I want to invite you to be with us for 1 hour. Hello again to Fabienne. Hello, Fabienne. Hello.
Hi. Hello, Carmen.
Hello. So I want to introduce you. Fabienne Gandon is a research director and senior researcher at INRIA in France. Fabienne's PhD in 2002 pioneered the joint use of distributed artificial intelligence and the semantic web to manage a variety of data sources and users above a web architecture. Then, as a research project leader at Carnegie Mellon University, he proposed artificial intelligence methods to enforce privacy preferences in querying and reasoning about personal data. In 2004, having been recruited as a researcher at INRIA, he began to study models and algorithms to integrate social media and knowledge-based AI systems on the web while keeping humans in the loop. In 2012, Fabienne became the representative of INRIA at W3C and founded WIMEX, a joint research team working on bridging social and formal semantics on the web with AI methods. In 2017, he established and became the director of the joint research laboratory between INRIA and the Quant search engine. The same year, he also became responsible for the research convention between the Ministry of Culture and INRIA, with a special interest for culture data and applications. And in 2018, Fabienne became Vice Head of Science for the Research Center of INRIA Sophia Antipolis, Mediterranean. Thank you. Welcome again, Fabienne. It's super exciting to have you here. And please, I give you now the moderator role and feel free to show your presentation. So I change now to you. Yes, I gave it to you.
So let me take that.
Yes.
Normally you should see The slides are now coming. Let me thank you, Carmen, for all your help, your invitation first, and all the help in preparing that. That was super efficient, perfect communication, perfect setup.
Yeah.
Thank you. Thank you, everyone.
Thank you.
Thank you, everyone, for joining us online. I hope I find you all well and safe right now. So I will skip that first slide because basically Carmen already presented me. I want to introduce the team that I'm leading, the research lab I'm leading in INRIA Sophia Antipolis in the south of France. It's important to mention, first of all, that it's a joint team between INRIA, CNRS, and Université Côte d'Azur. So you find people from all these organizations in the team. They all contribute to the research of WIMIX, which stands for Web Instrumented Man-Machine Interaction, Communities, and Semantics. One of the important things also is that these several of the researchers, as I will mention, are also part of a local structure called the 3IA. So the 3IA are, there are 4 of them in France. They are interdisciplinary institute for artificial intelligence, and they were created in 2019. They aim at boosting AI research, and the one in the Côte d'Azur on the south of France was created to boost in an innovative ecosystem to be influential locally, nationally, and internationally, and to help not only research but also education develop, to set up collaboration within academia, companies, and to actually build momentum and a community with an impact in terms of economic values, but also an impact on everyday life. And this local structure has 4 research axes, and you will see several of the research I will mention today are really in these axes. The first one is focusing on the core AI and fundamental problems. The second one is on AI for integrative computational medicine. Third one on computational biology and bio-inspired AI, and the fourth one in AI for smart and secure territory and environment. The reason also I mentioned that is that this 3IA has many calls that may be of interest to you who are connected today. Calls to visit for a researcher, for instance. We have a program for visiting researcher. We have program for industrial affiliates who wants to participate in the 3IA, so do not hesitate to look at this. Now zooming on my team, on WIMIX. WIMIX roughly have between 40 and 50 members accumulated in a year, 50 nationalities, and I actually listed the tenured people, the people with a permanent position here on the screen. I listed them, and in red you have their keywords. And I wanted to mention that because one of the points I will try to make today is that the research we're doing is only possible because we have multidisciplinary approaches. Because we have all these different profiles with different skills, we can address some of these the problem I'm going to mention today. I think it's really important. Before going a bit further, I will also try to make clear what I mean when I use the term AI, because it's been used for many things, and so to avoid any misunderstanding, the definition I will adopt here is that AI for me is the study of automation of processes that we humans recognize as intelligent, and so therefore it includes deducing, learning, reading, imagining, speaking, recognizing, you name it. This also means that inside AI you have many disciplines. Of course, machine learning, but also knowledge representation and reasoning, natural language processing, robotics, computer vision, constraint and satisfiability, multi-agent system. All of them, for me, are part of the AI disciplines and the AI ecosystem. And again, one of the points I will really try to emphasize that we always need to have a multidisciplinary approach. And this multidisciplinary approach will not be limited to the AI disciplines, as we will see, but to many others outside of AI. The challenge for the Wimix team when I created it in 2012 was summarized in one sentence: to bridge social semantics and formal semantics on the web. So on the web, you have both human, like us, contributing content in social media, for instance, interacting with very sometimes informal semantics, using natural languages, posting images or things like that on one side. And on the other side, the web is also used by machines to exchange data, as I will recall in a few slides. And the goal of Wimix is to provide AI methods to go from one world to the other, back and forth, and to bridge semantic web and social web back and forth. For that, we have 4 research directions in Wimix. One, which is looking at web-based user modeling and interaction design, so at the individual level, at the user level. One, looking at social interaction and content analysis on the web, so at the social level, collaboration, community, social media, social networks. Third one is looking at knowledge extraction and representation for and by linked data on the web. The idea is that when you have a user model, or when you have a community model, or when you have a model in general, we will look at how to formalize it using semantic web formalisms. And then web-oriented and web-dedicated artificial intelligence algorithm in order to process these model and to provide new functionalities and feedback to their user and their communities. One thing which is unifying these research direction in Wimix, that when you look at all the different facets of the web, websites, social media, web of data, web services online, semantic web with schemas, and so on, when you look at them, in fact, behind them, oops, sorry, I have a pop-up. Behind them, you can see that there is always a graph. Okay, so a graph of links between sites, and a social network graph, a graph of linked data, and so on. And what we are interested in is to look at all these graphs, but together in one unifying way, in one unifying formalism, to mix these different type graphs together in order to be able to leverage all of them together when we perform an analysis, when we do some calculation, when we apply AI approaches. So at the individual level in the team, you will find contribution by team members in many different subjects. I listed them here, and when I put a magnifying glass, it means in the rest of the presentation, I will mention them in more detail. So at the individual level, we work on exploratory search and interaction design, augmented browsing, privacy interaction design, natural language access to data, such as question answering, emotion in user profile, how we represent them, for instance, with an ontology, educational interaction, music content interaction, or assisting robot interaction, so augmenting our interaction with a robot. At the social level, the kind of topics we work on include detecting and labeling communities of interest, detecting events on a social media, detecting emotion and using emotion in a debate, together with the following topic, which is argument and opinion mining in social media. One application also with partner in Italy was in cyberbullying detection, capturing microculture, for instance, in Africa, or multi-agent approaches for recommending system. And the new topic is around hypermedia agency, which is using multi-agent system above the web. In terms of creating schemas of formal model and publishing data on the web, and especially linked data, we worked on vocabulary to represent software development, time. We also worked on formalism to capture the validity, completeness, or uncertainty of some data. Again, model to represent educational data or data about the students, but also about the content, zoological knowledge, biodiversity, legal knowledge. And we are also in charge of several activities, especially in terms of knowledge extraction. For instance, we are hosting the French chapter of DBpedia. We worked on data sources integration and especially legacy sources. We are interested on online name entity extraction. For instance, when you're browsing, lyrics analysis is one of the project which is finishing in Wimix right now. Argument mining is a very hot topic right now. I will come back to it. and also learning background knowledge by reading, especially for robots, for instance. And finally, for the last research direction, example of topics include transforming linked data or programming on top of semantic web. The idea being to provide programming languages that help you program your application or your agent on top of the web and its data. And I will come back to that when I talk about the work of Olivier Corby and the team. Handling distributed linked data, also testing axioms or vocabularies, part of vocabularies against RDF data, the idea of inducing vocabulary or finding axioms from the data, rule discovery, computational models for argumentation, and so on. I will not go into the detail of our teaching activities, but of course we teach also on all this topic. And one of the things we do is we provide free MOOCs, freely available. So on the FUN platform or on Coursera, we have MOOCs on these different aspects, especially the semantic web and linked data aspect. And we also try to transfer results to industry through several collaboration. I will not mention all our collaboration. I just want to say that, for instance, we have an activity of incubating and creating startups at INRIA, and one of the spin-off of the WIMIX team is called Mnemotics, and it is a cooperative company which is in charge of providing services and tools in this domain of semantic web representation, knowledge management, and so on. Okay, so that's all for the team introduction. Now I will dive into some of the topics. The first set of topics are about the web becoming a universal space to link data. So I split the presentation on the different aspects or different resources the web is starting to link. And first I will talk about data. This is not a new idea. This is a paper from Tim Berners-Lee dating from 1994. And if you look at the yellow part of this paper here, already at the time, he was writing that we needed to design an evolution of the web from a web linking objects that are principally human readable documents to a web that contains more machine-oriented semantic information, allowing more sophisticated processing. So in 1994, the web was really just taking momentum, but he was already writing in his paper at the time that one important evolution of the web would be not only to provide linked resources for humans, but linked resources for machines. And this led to the development of the semantic web, web of data, linked data on the web, the global giant graph, you name it. That led W3C to create a number of recommendation standards to actually publish data on the web, transform them, reason on them, query them, and so on. All of these little blocks here represent a standard or a recommendation or principles from W3C to publish data and schemata on the web. And we work on nearly all of them in WIMIX. The result of applying these recommendations on the web, on adopting them, was the growth of the linked open data set on the web, which is known as, and one of the representation of the linked open data set, the biggest one, is known as the cloud, linked open data cloud, that you see here, and its evolution around the world, the years. And as you can see, there is a tendency for more and more people to publish their data using these formats, these recommendations, and therefore to make them available to any program that knows how to connect to the web of data. The principles behind that are very simple. The idea is that when you find a URI in your data, such as this one, and you don't know what it represents, there is a very obvious thing to do because it's a HTTP URI. You can connect to it, and if you are a human and you do an HTTP GET, which is the equivalent of opening your web browser on this address, you will get a document for a human in HTML that explains the data about this resource that was identified by dbpedia.org resource Paris. But the very interesting thing that if you use the same URI, the same HTTP URI, the same address, but if you are a machine and you go to the same address, because we have a content negotiation mechanism on the web, you will be served data, not HTML for human, but data that you can load into your database. So any of these sources I mentioned earlier, they apply that in order to provide data both for human and for machine on the web, so that the machine can learn these data, load them in the database, and query them, reason on them, mine them, whatever. And the very important point is that whether you are looking at the result for human or for machine, they are linked data in the sense that the data you get contains link to other resources, other data sources, so that you can follow this link and discover new sources, new data sources, new resources, new descriptions. So just like we click on blue links on the web and discover new pages, the machine can follow these links in their data and discover new data about France from Paris, and then from the France discover Europe, and so on. So for instance here, if I go to this URI, if I am a human, I will discover it is a protein, and I can read about that protein. But if I am a machine, I will get data about that protein. I can load it in my local protein database. So what I just said is that the web has become a place where AI can get a lot of data. And not only by scraping the web, or by having labeling activity, or by crowdsourcing, which are all sources of data for AI, but also through direct access to structured data published on the web. So the web is this place where invisible brontobites graze furiously, we could say. So I mentioned in Wimix we participate to that. We created and host the French chapter of DBpedia, which extract RDF data, link data from Wikipedia and publish it as structured data that can be then reused in different applications. So we maintain a public endpoint where any of the programs you want can connect, make some queries, and get data on aspect or categories or subject that are of interest to them, so cities, art pieces, or things like that. One of the first example of research work I wanted to mention we do in that direction is to start to help taming this web of data. So one of the things we've been doing in joint project with Quant is to see if we can help them crawl this new wealth of data. Because when you crawl the web, you know that even before you start, you know you will not succeed to crawl the entire web. You know it's getting bigger and bigger, and you know it takes a lot of time, especially every time you have discovered an address. What takes a lot of time is to access this address, get the document, and start to index it. So one of the things you would like to do is to predict whether or not an address is interesting for you or not, before deciding to crawl it, really, to index it. And so one of the things we worked on is to train machine learning algorithms to learn the patterns of URIs in order to predict whether a given URI is going to provide you some data. And when I say data, I mean structured data. So data for a machine, not for a human. And so it can be RDF directly, it can be RDFA in a page. But the question is, can we learn the patterns people use for their URIs, for their naming, in such a way that we can predict and therefore in advance decide to access or not that source? And so the result you see on the screen were actually presented at the European Semantic Web Conference, and they got the best paper award because indeed we show we can predict them and we can use them to help a crawler decide to crawl a given part of the semantic web or of the web or not to get data. And what we are doing now, the current work we're doing with that, is to use this kind of knowledge we have now by crawling the sources and finding the sources to provide interfaces where you can make structured query to the web of data without knowing which data sources should be used to answer your query. So to let the system decide which data sources should be used when solving your query. So this is the current work of Hai Wang in the team. And of course, there are many different applications that use the link data on the web. I'm not going to mention them. I just wanted to say that, for instance, one of the scenarios we pursue in the team is to use that in educational environments. So for instance, because we have all this data, of course, we can think of usual application of the web, such as search engine, but we can also do the opposite. Instead of answering your question, we can ask you a question. And why is it interesting? Because you can generate quizzes in a domain in order, for instance, to train students. So using the data that are on the web, we worked on the automatic generation of quizzes, again with Quant, and also in collaboration with a company which is called Les Incollables in French, which generates games, quizzes for children, for everyone actually, to play and to train in a different domain. And what we help them do is to generate new quizzes in the domain they already have, by using the data on the web to suggest possible questions, their answer, and possible distractors for the answer, so that is plausible false answers. We also now work, and that's the current work we're focusing on, using prediction algorithm now to predict the results of students in a learning environment to a question before asking the question. And the idea is to use that in order to find the best pedagogical path for a student to make progress in a given curriculum. So here we represent, using semantic web formalism, both the questions and the answers of the different students to this question. And we use that together with a number of features on the graph, including some knowledge graph embedding of this graph, in order to predict the result of a student to a given question, and to decide whether or not this question is a good question for him now, or if we should choose another question for him now. So after linking data on the web, the second aspect I wanted to insist on is that we don't only publish the data on the web, we publish the schema of the data, the different schemata of this data, and they are also published and linked with the same mechanisms. They are useful because they can be exchanged between reasoning engine, for instance, algorithm automating deductions. They can use that to exchange these schemata and enforce some inferences with all the difficulties we know about them. They can also be used by other algorithms. So for instance, the same schemata providing classification and categories, they can provide labeling information to train a learning algorithm with all the difficulties we know about them. But again, the fact we can publish this schemata can be used both in reasoning and learning. And for that, there are a number of formalism, again, provided by W3C for that on the web. The most well-known being OWL. Here is a slide that summarizes the OWL language in one slide, explaining that it allows you to define the classes, the categories you have in your data in terms of union of other classes, or disjunction, or intersection, and so on. All these operators you have on the screen provide logical expressivity to define your schema and to define the rules that can be applied to the data using that schema. And the schema, when they are published on the web, just like we saw a cloud of linked data set, they also have their cloud. Currently, there is a service hosted at the Universidad Politécnica de Madrid, which is LOVE, Linked Open Vocabulary, that shows some of the most well-known vocabularies, schemata that are published. And they actually show the social network of this schema, showing which are the most used one, what are the links between them, and helping you choose a schema when you have to represent data and if you want to reuse it. On top of these schemas, in my team, we work on different AI algorithms to reason, query, learn data using these schemata. So there is a work by Olivier Corby in the team I think it started in 1999, providing a Cores engine, which is an open source engine to reason on this data, query data that are represented using graph formalism, especially RDF, but also transform them and program on top of them. I will come back to that. We can also use the same formalism and standard to look at other questions, such as can we predict in advance what will be the cost of a query to this data, and if we want to pay that cost in terms of time or complexity. Can we induce new data? Can we detect missing data in a knowledge base? So that's the work of Andrea Tetamenzi in my team, where he will look at a base such as DBpedia and try to find if some piece of knowledge is missing in the base and suggest this addition to the base. So for instance, to suggest that we forgot to say that a launchpad is a subtype of infrastructure in DBpedia, which is a real case. And of course, you can imagine many other different types of reasoning. One of them done by Serena Villata is deontic reasoning in order to allow us to reason on licenses, and especially licenses attached to the data, which is interesting as soon as you have AI techniques using and combining different data sources, because these different data sources may have different licenses, and therefore the question that will arise is, are they compatible? And if so, what should be the license of the result of my computation? And that's exactly the kind of challenges Serena is trying to solve. So, because we are in AI for EU Café today, I wanted to also mention some of the contribution of the team to AI for EU, especially the work of Olivier Corby. What we are contributing to the team is through the work of Olivier is the work on the ontology for AI itself, we could say. That is an ontology that was designed to help us annotate and publish metadata about AI resources, and especially AI resources published all around the world. But also how we validate that, how we validate the graph, the RDF graph that are generated for this annotation using another W3C standard, which is called Shackle. And one of the deliverables was the provision of an online semantic web server with a SPARQL endpoint, where you can query this data about the different AI resources. And I put the URI here, coresinria.fr. And you can play with predefined SPARQL query, Shackle shapes for validation, and a number of graphic display of the ontology and the metadata. Another timely topic I could mention is one of the things we've been doing in the past 3 weeks now in the team is to work on publishing and validating and enriching COVID-linked data. So we worked on using the techniques I mentioned to integrate multiple data sets in heterogeneous formats, so CSV, JSON, everything back to RDF and published in RDF. We perform also information extraction from text. So for instance, a scientific article about the COVID are analyzed using name entity recognition to extract the topics they are talking about, and these topics are represented in RDF and published. And we now work on performing inferences, validating the data, ensuring the stability of the public endpoint we are providing, and providing querying and visualization service on top of this COVID-linked data. So, am I on time? Yes. Fourth aspect, the web is now not only linking documents, data, and schemata, it's linking programs. It's linking more and more programs all around the web. In fact, one could argue that the web is can no longer be perceived as a hypertext or a hypermedia of data. It's more and more looking like a hyper program, where we are linking together more and more programs around the world through the web standards. So if you look, for instance, at this growth of APIs on the web published since 2005, clearly the number of programs that are connected to the web and that are providing a web API so that other web clients or web application can connect to them is growing. Okay. To assist that, we've been working on several topics in the team. One of them is to bridge the gap between this API view of the web and the data view of the web. And the way we've done that is through the work of Franck Michel in the team, which can be called microservices or Sparkle microservices that allow you to transform web APIs into data sources, into virtual data sets, Sparkle endpoints that are published and documented as such, and that can be called just like any other data source. So a Sparkle query can then use them just like if there were Sparkle endpoints or data set published, independently of the fact they are in fact web APIs. So you can see an example here on the screen of an application to the domain of to the Natural Sciences Museum of Paris, where you can see in one page an integration about dolphins having data from inside the museum, so internal databases, but also data they found on Flickr in terms of photos, or on Spotify, Music Brains, in terms of sounds that were recorded about these dolphins. And they are presented as if they were an integrated source of data. And what you also see on the right is that because we now are able to present these APIs as dataset, they can be crawled and indexed by usual API and dataset services, such as the Google Dataset Search. The Google Dataset Search was able to index that source as if it was a dataset, but in fact, it's a microservice which is masking an API. Another way we help bridging the gap is the work of Olivier Corby in the team. Again, he worked on providing programming languages on top of linked data so that we can directly program the application and program I mentioned with languages that consider the linked data formalism and data as first-class citizen. So you can directly program in a language where RDF graph as our first-class citizen can be manipulated easily, and you can program your algorithms directly on top of this view of the linked data in order to bridge the gap between linked data and the web of data, let's say, and the web of programs. Why is it interesting to be able to do this integration of APIs, of program, of data? One of the first scenario I think that we had in the team through the defense of habilitation of Freddy Lecu in our team was the case where he was working at the time at IBM Dublin and working on smart cities for Dublin, and he was collecting clouds of sensors such as the big red cloud you have here on the left. And one of the first things he did was to import data from the linked data, but also from APIs on the web in order to enrich this data, not because he didn't have enough data, but because he wanted more dimensions, more semantics. And why is this interesting? Why do you want to augment this data with external data? It's because when you do that, you can start to type things more precisely. And these additional typing and dimension you have, they can be used then when you do the mining to aggregate things and also to explain things more easily. So for instance, because you know there is something happening on a road, you can then link that to the fact there is a concert of Madonna close by, and that maybe there is a link between the event you know from Eventful and the sensor activity you see on your smart city grid. Another example of putting all this together is using that to allow robots to be more intelligent in their interaction with us. So for instance, here in the Alouf project, we worked with this robot that seems to be escaped from Doctor Who, by the way. And what we provided is an ability for the robot to go on the web and learn additional knowledge about the object we were mentioning, so that it would be more intelligent in its interaction. So for instance, if you ask it to fetch a spoon, instead of just starting image recognition to find a spoon, what the robot is able to do is to learn from the web that the usual location for a spoon is the kitchen, and that therefore a smart move before starting image recognition is to move to the kitchen and then start your recognition. So for that, we use a natural language processing techniques to do learning by reading on the web. But also we use semantic web technique, because as soon as one of the robot learns that, it puts it in an RDF database, which means all the other robots that share the RDF database with this robot also learn this knowledge. So by using the web as a link between the robots, when one robot learns something, the other robots also learn it. And last example of merging all of these is an example on predicting hospitalization, where we use data from physician records. And the idea was to try to predict hospitalization from that. But what we were really interested in is what was the impact of augmenting these records with knowledge from the web, medical knowledge from the web, before doing the prediction. So knowing that a given drug was mentioned, detecting that drug, linking it to the ATC ontology and importing knowledge about that drug has an impact on our ability to predict the hospitalization. So using the web to inject data before doing the learning. So what I'm saying is that putting this data and schemata on the web, we can use them to do, of course, inference and deduction. We can use them to do learning, but we can use them to do both, so learning and deduction. More interestingly, we can deduce from what we learn and learn from what we deduce. So that's starting to be interesting coupling of algorithm. And here the web has a key place, because it can be the space where we make the different approach remotely combined. And not only about the data, the input or output, but also about the schemata or ontologies, about the data, about the embeddings, about the parameters, configuration. All of this can be represented and exchanged through the web. So the web is a way for me to combine many of the different AI approaches we have right now. In other words, the web has a potential to be a global background for artificial intelligence. I'm going to skip that one and move to the last part, because I have only a few minutes left. So I try to make the point that the web has become a universal space to link data, schemata, and program. And in fact, it's linking intelligence in general. I mentioned that we worked on representing user, and these users are a type of intelligence, the first type of intelligence that connects to the web, whether we represent their context of interaction, their communities, and the different topics that bind these communities, or an ephemeral state about that user, such as an emotional state detected and represented and published in RDF. One of the work we do currently in the team is to represent, for instance, the argument that I exchange in clinical trials online. This is currently being ported to the COVID corpus, by the way, in order to analyze the article and to extract automatically what were the debating argument between the authors of these different articles. You can do the same in the political domain, and we did it on 39 political debates over the 50 years of US presidential. And you can have the same techniques, for instance, to detect exchanges or patterns on the web, especially on Twitter, such as Encrypt, for instance, to detect cyberbullying attacks between children of a school, and to try to prevent the effect of these. So what I'm saying here is that when you look at the communities we have currently online, such as a community like the Wikipedia editors that you have here, you have the 50 most prolific editors of Wikipedia with the number of edition act on Wikipedia. But when you look at this curve, the reality of this curve is that if I only take, in this curve, if I only take the humans, here they are. Here on the curve now, you only have the humans. The rest of the communities are robots, are bots that are implementing more or less intelligent algorithms. So this idea that we are editing Wikipedia is not completely true. Wikipedia is actually maintained by hybrid communities of natural intelligence and artificial intelligence. And this situation is going to grow and be a trend for the entire web. it's also going to be pushed by the fact that the web is continuing to evolve in many directions. So one of them is the web of things. We are connecting more and more things. These things, they come with their APIs, their application, and again, they will be linked to the web and start to interact with other applications. And we're not only linking artificial intelligence or human intelligence, we are linking all kinds of intelligence to the web. When we connect animals, when we do herd sourcing on the web by monitoring collective animal behavior, for instance, to detect sign of an earthquake or some problem, natural problems, we are again connecting different kinds of intelligence to the web, and they all come to a one and unique place, which is the web. So what I'm saying here is, let's imagine a web where we are linking, in fact, all forms of intelligence. And I believe this is the real potential of the web. I believe the web should become a global blackboard for all kinds of intelligence. And it's also echoing some very old aspect of AI. If you look at AI as it started in 1955, at the same time, you had other disciplines starting, such as IA, which stands for intelligence amplification and intelligence augmentation, where the idea was to focus on the human and augment the intelligence of the human. And it's really interesting for me to remember that, because right now a lot of people are trying to put human back in the AI loop, but IA was starting from that, from the human to augment it. So I think, in fact, web has a rendezvous, has a potential to be the rendezvous point for the two fields that were born in the 50s, which were AI and IA. But for that to happen, in front of the 3 W's of the World Wide Web, we must put the 3 M's of massively multidisciplinary method. And we must really understand that metadata on the web and data on the web are extremely important, because they are the one describing everything we are connecting, all the programs, all the resources, all the intelligence. And these should really be monitored and distributed, because he who controls the metadata controls the web, and through the web, many things of our world. Thank you for your attention.
Thank you, Fabien. It was hyper interesting. I see the time running, and I will ask you now questions, because the participants have asked some. I will first give the chance to the participants, because I have also questions, but here I start with Radu Stefan. What is the quality of the data? In other words, who assumes responsibility for the correctness of the data? I am aiming at manipulation of AI by intentionally providing false and misleading information.
So this is an excellent question. So first of all, let us be really clear about one thing. The web is a garbage. You can find all sorts of things on the web. The semantic web will be a semantic garbage. Okay, let's be clear. Everyone can publish anything about everything. But the good news, let's say, about that is that because we have this formalism, because we have schemata, because we have shackle validation, we can now have ways to validate some of the data. We also have a program recommendations such as Provo, which is a provenance ontology that allow you to do traceability of the data, to know where it comes from, how it was obtained, which algorithm was applied to obtain it. And all these together, they can start to provide clues or criteria for you to decide whether or not you want to use a given data set. So for instance, now if you find a data set and this data set is annotated in Provo, and it says it was obtained by a given algorithm that you don't trust or you don't like, or that this algorithm used some sources you don't trust or you don't like or you know are biased, you can decide not to use the data set. So I'm not saying we have the answer. All these are still starting and deploying, but people are aware of that, and they're starting to contribute to that by providing traceability means, validation means, coherence checking means, and so on.
Thank you. And now I have a next question from Faiz Ikramola. and I'm reading them because he tried to have several. How long has Quant been around? Because he just discovered it some time ago. That's the first question. How long is Quant around? And secondly, how is Sparkle different or better than SQL?
Okay, so the first question. So I'm in charge of the joint laboratory between INRIA and Quant, but I'm not. I'm a disclaimer. I'm not an employee of Quant, and I'm not speaking on behalf of Quant at all. I'm in charge of this joint structure. I think the first time I heard, I talked with the creator, the founder of Quant, was in 2014, I think. But I wouldn't bet how. I'm not completely sure when it was officially created, so I won't answer that question on that. And the second question was, sorry, Sparkle and SQL. So Sparkle is I wouldn't say one is better than the other. They are from two different worlds. SQL is designed to query relational databases. Sparkle is a graph query language for RDF graph. So it was designed to be able to query graph patterns on top of RDF. And for that, it is efficient, and it has a specificity such as the ability to query a path between different resources, which is interesting, for instance, when you use social network data. So there are different languages. Sparkle is from the web world, and for linked data on the web, graph querying data. SQL is from the relational database and is really designed for the relational data queries.
Okay, thank you. I get hellos from James Crowley, and from Peter van der Linden, just saying hello.
Hello. Hi.
They cannot show, so hello from them. And here comes a question from Loretta Anania. The internet is larger than the World Wide Web. How do you see the future of search based on the progress of methods in AI querying?
So I'm not. Can you repeat the question? I'm not sure. So I agree completely with the fact that internet is bigger than the web, because in the sense that internet and the web are two different things. Internet is this inter-networking infrastructure we have.
Yeah. How do you see the future of search?
Oh, so so one of the things. So you all know that the predictions are hard, especially when they are about the future. I will not do that. But what I can say is what aspect of the search, for instance, we are working on right now, because we believe they need to be improved. So in the team, for instance, we have been studying a special kind of search engine, which is called exploratory search engine, that allow you to search the web for topics or domain you don't know. Because a number of search engines now, such as the biggest one, they are designed for searches for which you already have an idea of the keywords you're going to provide. So it means you already have some keywords to enter a domain. But if you want to discover a completely new domain, you don't usually don't have the keywords to enter that domain. So it's a kind of search which is not very well covered. And that's an example of types of search engine for which AI techniques are used to provide new way of searching, new way of recommending, new way of helping you formulate your search, reformulate it until you discover a domain or a topic. So that's an example of domain. And also you can imagine, to link the two parts of the question, one of the things internet is currently bringing to the web is the Internet of Things. Okay, so the more we connect things to the internet, the more also they become visible to the web application layer. And we have there is a domain called the Web of Things, where people work on linking the thing at the web domain. But one of the questions in terms of search is, what would be a search engine for the Web of Things? What would it look like? How should it perform? How do you have a search engine that finds your private objects, but also the public one around you, without having any problem with your privacy, for instance? All of these are search scenarios for the future.
Okay, thank you. And now Peter comes, Peter van der Linden. Hi, Fabienne. Thanks for the presentation. With respect to the question of trustability of data, we had a presentation last week of a gentleman, this was Sukesh, proposed blockchain for traceability of data. Have you considered this? It's about blockchain, no?
So yes, at W3C, there are several working groups have been working on standards for distributed ledger representation, standardization on the web. And so you do have that. And also some people have been working on the specific problem of using blockchain together with linked data. So the different questions that have been covered, for instance, is can we use a linked data structure inside the blockchain? Can we represent it? Or can we have a data structure that link both well, for instance, to use the blockchain to certify a given graph of linked data? So to be sure that the graph you are currently considering on the linked data is authentic, is the right one, by checking something on the blockchain. So both by merging the data model or by making links between the two of them in order to move from one world to the other when you need to certify to move to the blockchain and when you need to search or do some querying to move back to the linked data.
Okay, thank you. I just wanted to say here, Christoph Servan gives us the answer about Quant, that Quant was created in 2013. Thank you, Christoph. So we do know now. Thank you. Yes. Peter also says thank you. And I think the last question now, because time is running. So anybody who doesn't get his question answered, you might forward it to me or to Fabienne. But now comes the last question as time is running. Luca Pedetti. Dear Carmen, can I ask Fabian? Yes, you may, Luca. So, what could be, in his opinion, the best way to create secure and trustable metadata? Maybe it's only around the regulatory standard as normatives or laws.
Wow, can you repeat, please?
Repeat. So, what is, in your opinion, the best way to create secure and trustable metadata? Maybe, he suggests, it's only around the regulatory standard as normatives or laws?
So I will. So first of all, I will insist on the fact that I'm probably the worst guy to answer, because I just said that this kind of problem need multidisciplinary approach. So that would be, for me, that would be a strategical mistake to ask a computer scientist guy like me to come up with a technical answer to something which is a multidisciplinary problem and that needs lawyer around the table and things. What I can say, however, is that the answer, the web can bring several things to the table. None of them are the perfect answer, but all of them contributed in the past. One of the things brought to the table is the fact that everyone can say everything about everything. This allows you to publish your data, and if your data are not good, there is a high chance by publishing them that someone will spot them. So by publishing things, there is a social regulation about the data where people are going to use the best data or the best schema, and there will be some kind of natural selection. That's one of the mechanisms on the web. But again, this is one of the many mechanisms that exist. And the second thing I can say also is that we are entering another problem on the web, is that the web knows no jurisdiction. There is no jurisdiction on the web. And so whenever you come up with a regulation or a law, this one is defined in terms of a jurisdiction. And the immediate problem you have is that this law stops to be effective outside that jurisdiction, but the web continues outside. So, of course, it can participate. We all see that RGPD has an impact. Although it's a European initiative, it has an impact all around the world. So I don't want to oversimplify the problem. But again, we need to put on the same table economists, because they have incentives to push people to put better data, jurists, because they know how to frame it in terms of law, computer scientists because they can help us with some verification methods, sociologists because they know how to create collaboration means that will converge toward better quality, and in general, multidisciplinary approach.
Yes, thank you. Thank you for the great answers, and I will now stop the question session. I do have the questions from two ladies, which I will forward to you, Fabienne, so maybe you have time to answer them afterwards. But now I will take back the transmission. I will be the moderator. I will just share my screen because for the last minute, I want to invite you tomorrow. We have a special on COVID, the fight against the coronavirus pandemic. And we have the Circ protective half mask. It's interesting because they have a license to print with 3D printers masks, which are so desperately needed in the moment. And then we have a guest speaker of Caribus, who has even more masks and wearables which you can use in COVID-19. Very interesting. You can print it all. It's used from India to South America in countries where the money is not so high. And so if you feel like joining, I'm looking forward. So it's tomorrow at 3 p.m. Thank you again, Fabienne. This was a great session. And have a good afternoon, everybody who was today there. Thank you that you all came, and stay safe, everybody.
Thank you. Stay safe. Bye-bye.
Bye-bye. Bye-bye. Bye-bye.